Welcome to the today's tutorial. Today we are going to discuss about the derivative of inverse trigonometric functions. First we will record about the inverse of trigonometric functions. Side you have the original trigonometric functions well known: sine, cosine, tan, cosecant, secant and cotan. On this side we have the inverse trigonometric functions which denoted as like this: sine inverse x, cosine inverse x, tan inverse x, cosecant inverse x, second cotan inverse x. It's also sometimes denoted as arc sine x. Next, we'll recall some basic properties of the trigonometric function, and in this process, we will discuss the one trigonometric functions, and rest will be almost same. So let's have sine, sine and sine inverse. So domain for the sine is, we take pi over 2 to pi over 2. So this is the domain for the sine, and range is -1 to 1. Then sine inverse, domain will be -1 to 1, and range is minus pi over 2 to pi over 2. Then the property is satisfied: sine inverse x, this will be x is equal sine inverse sine x. This property also holds for all functions: tan inverse, cotan inverse, cosecant inverse, like that. Okay. Now, how to get the expression in terms of x if it is combination of the other function? For example, if we have cosine of sine inverse x, then we know that cosine and sine is related by cosine square x is equal 1 minus sine square x. So using that, we will have here 1 minus sine of sine inverse x, and this whole square. So this is equal 1 minus x square. Same way, if we have say tan sine inverse x, how we can change it to the x? So tan, we can write it sine of sine inverse x, and cosine of sine inverse x. So sine inverse x will be x, and cosine, it will be 1 minus x square. Similar way, if you have second sine inverse x, so how it can convert it? We can write this is as 1 over cosine of sine inverse x, which is equal 1 over square root of 1 minus sine of sine inverse x whole square. So this is equal 1 over square root of 1 minus x square. Next property also very useful in the future calculus part. So we have sine inverse x plus cosine inverse x is equal pi over 2, and then tan inverse x plus cotan inverse x is equal pi over 2, and secant inverse x plus cosecant inverse x is equal pi over 2. This table, if you see that, if you know the derivative of sine inverse x, tan inverse x, secant inverse x, you will automatically get the derivative of cosecant inverse, cotan inverse and cosecant inverse. Then, so let y is equal sine inverse x. This implies x is equal sine y, which is equal cosine pi over 2 minus y. This implies cosine inverse x is equal pi over 2 minus y. This implies y plus cosine inverse x is equal pi over 2. So this implies sine inverse x plus cosine inverse x is equal pi over 2. Next is the derivative of y equals sine inverse x and y equal cosine inverse x. So let's recall the derivative of inverse function. Derivative of inverse function, which is say d dx of f inverse x is equal 1 over f dash f inverse x. Now for this case we have f of x is equal sin x and f inverse x is equal sin inverse x. So therefore d dx of sin inverse x, this is equal 1 over f dash sin inverse x. Now f dash is cosine x, so we'll have here 1 over cosine of sin inverse x, which as we discussed before will be 1 over 1 minus x square. For the cosine inverse we can go it directly, but we'll solve it by this way. This is equal d dx of pi over 2 minus sin inverse x, which is equal 0 minus 1 over square root 1 minus x square. So minus 1 over square root 1 minus x square. This is the derivative formula for the sin inverse x and cosine inverse x. Let f of x is equal tan x and f inverse x is equal tan inverse x. So d dx of tan inverse x, which is equal 1 over f dash tan inverse x, where f dash is equal f dash x is equal secant square x. So this is equal 1 over secant tan inverse x whole. We know that secant square theta is equal 1 plus tan square theta. So This can be written as 1 plus tan of tan inverse x whole square. So which is equal 1 over 1 plus x square. Now if you need the cotan inverse, so d dx of cotan inverse x is equal dx of pi over 2 minus tan inverse x, which is given as minus 1 over 1 plus x. Now we'll write the general rule which is need to memorize for the derivative of the trigonometric function, and applying chain rule we will have d dx of sine inverse u x is equal 1 over square root of 1 minus u square and du dx. d dx of tan inverse ux is equal 1 over 1 plus u square du dx. d dx of second inverse ux is equal 1 over square root absolute value of u square root of u square minus 1 du dx, and then the fourth, fifth, sixth will be the repeated of the first three, only just add the minus 1 in the as a coefficient. So d dx of cos is y equal tan inverse 3x plus tan inverse 3x. Solution y dash is equal d dx of tan inverse 3x plus d dx of tan inverse 3x. But tan inverse 3x is equal 3x. So this is, we have applied the chain rule here. 1 plus 3x whole square derivative of 3x plus this is d dx 3x. So this is equal 3 1 plus 9x square plus 3. If we combine them, we will get it here. 3 2 plus 9x square 1 plus 9x square. Next is y equal ln cosine inverse x plus secant inverse 2x. dy dx is equal d dx of ln cosine inverse x plus d dx of secant inverse 2x. So d dx of ln x is equal 1 over x, and if we generalize this chain rule, d dx of ln ux is equal 1 over ux du dx. So with this we will have here 1 over cosine inverse x derivative of cosine inverse x, and derivative of secant inverse x is 1 over 2 absolute value of x square root of 4x square minus 1 d dx of 2x. So derivative of cosine inverse is minus 1 over cosine inverse x square root of 1 minus x square, and here derivative will be 2. So 2 absolute value of x square root of 4x square minus 1. So this 2 cancel out. This 2 and this cancel out. So we have the answer. So this is the final answer. Next, find y dash x if y equal cosine inverse x over square root of 1 minus x square. So here we can solve this by the chain rule and the cosine rule. Dy dx this is equal 1 minus x square minus square root of 1 minus x square 1 minus x square minus cosine inverse x, derivative will be minus 2x over square root of 1 minus x square by chain rule. So this will gives you minus 1 minus plus 2x cosine inverse x over square root of 1 minus x square, and denominator is 1 minus x square. So this is equal 2x cosine inverse x minus square root of 1 minus x square over 1 minus x square to the power 3 over 2. Y dash is equal 1 minus sine inverse x and 1 minus sine inverse x, and this derivative will be minus 1 over square root 1 minus x square minus 1 plus cosine inverse x, and here derivative is minus 1 over x square. So therefore the answer is minus 1 over square root 1 minus x square, take out, and here we will have 1 minus sine inverse x minus 1 minus cosine inverse x 1 minus sine inverse x whole square, 1 over square root of 1 minus x square sine inverse x plus cosine inverse x 1 minus sine inverse x whole square. So you will get it here pi over 2 square root of 1 minus x 1 minus sine inverse x whole square. Here you have the product rule, y equal x square minus tan inverse x multiply 1 plus secant inverse x. So simply apply the product rule, you will have the answer. Solution dy dx is equal x square minus tan inverse x derivative of 1 plus secant inverse x plus 1 plus secant inverse x derivative of x square minus tan inverse x. So this is equal, just put the derivative of the inverse function. So you will have x square minus tan inverse x, and here the derivative is 0 plus 1 over absolute value of x square minus 1 plus 1 plus secant inverse x, derivative is 2x minus 1 over 1 plus x square. So we don't have much simplification here, so we can just write it the final answer